Hello everyone, welcome back to my channel. In today's video, we will understand the conceptual difference between reliability, availability and safety. In the field of reliability engineering, these terms are frequently used. However, their essence and significance may not be fully understood and captured. Today, I will explain these concepts from my own experience as a reliability engineer so you can confidently use these terms in the right context. So let's begin. We all know the definition of reliability. It is the probability that an item will perform its function adequately in its intended environment for a specified period of time. Reliability is expressed in probabilities, as we know, and estimated from failure distributions such as exponential, Weibull, etc. Now, this is the mathematical side of reliability. But here we will stick to concepts and reasoning to gain good understanding. I have shown here a car that is broken down and a laptop that is also not working. Does this mean these are unreliable systems? The answer is no, because reliability comes from the world of probabilities. It is not a 1 or 0. A laptop with a reliability of 0.99 can still fail and even fail in a short period of time. So, by definition, reliability is not a guarantee of survival. It is a population statistics term and should be used in that sense and mainly to compare two or more designs. So, what is the essence of reliability? Now, reliability focuses on minimizing product failures. How can I reduce the number of failures and get a reliable product? Now, in this case, how to design for higher reliability is the question. Now, the answer is given here. By utilizing good quality components from reputed manufacturers so that the product being designed can deliver what is expected. Using designs or components that are already proven in field. In this way, you have confidence and you will not get surprises. Thirdly, and simply, it is to employ redundancy. And finally, always comply with international standards. Look for a standard that will apply to the given task and comply with it. It will save you future headaches and give you a reliable product. Then, what is the significance of reliability? When does reliability become important? When do suppliers or buyers start thinking about reliability? They do so when the economic cost of failure is high. For example, when buying or selling a car, we tend to be forgiving when cheap products fail, but reliability is absolutely essential and important when large cost is involved. And secondly, when the brand image of a manufacturer is at stake, they ensure high reliability in those cases. For example, the Apple iPhones. Let's move on. The second term to be discussed is availability. By definition, it is the fraction of time a system is up and running, while reliability addresses failures and how to minimize them. Availability addresses the aftermath of failures, that is, repairs. As seen here, the broken car and the broken laptop both are repairable systems. If so, how can we quantify their availability? That's where the essence of availability comes in. It focuses on keeping the system up and running despite failures. Now, this is the well-known formula for availability, which is the nothing but the ratio of uptime to uptime plus downtime of the system. How can one design for higher availability? By controlling the downtime of the system, as we will see now. Firstly, through quick failure detection in the system by means of diagnostics. Now, the diagnostics that are put in the system have the capability of instantly detecting failures when they occur. Secondly, through quick replacement of failed parts with spares by means of having a modular design. By modular design, I mean, for example, in the case of embedded systems, you have a separate power supply unit as a module, a separate logic unit as a module, so that failure detection becomes easier and even replacement becomes easier. Now both of these factors, that is quick detection and quick replacement, will reduce the downtime of the system, thereby enhancing availability. The third way of enhancing availability is redundancy. If one item fails, the other is available for taking over. Now, when does availability become important? It becomes important when a system failure can result in mission failure. That is, the failure of weaponry systems, for example, in warfare can result in the defeat of a nation, can result in the defeat of a mission. That's when the availability of systems becomes highly important. Secondly, when the human cost of failure is high. In the case of airplanes, they specially make use of twin engines to ensure high availability even after one engine failure. As we know, there is no scope of repair on the flight. Finally, we will look at the term safety. Safety is basically freedom from hazards or accidents, while reliability and availability focus on failures, minimizing failures and even repairs after failures respectively. Safety lays emphasis on protection of humans, environment, infrastructure, etc. from destruction and harm. While reliability and availability are expressed in probability, simple probabilities, safety is expressed in probability of failure on demand. We call it PFD. That is, it looks at what is the probability of a system to fail when there is an actual demand on the system to take a safety action. What is the essence of safety then? Safety focuses on taking fail-safe actions upon system failure. For example, a pilot deciding to land the plane after noticing a glitch in the control system. How to design for higher safety? That is, taking timely actions to prevent accidents. That is, shutting down a nuclear power plant when there is a leakage in its primary heat transport system. If accident occurs, you take mitigating actions to constrain the damage. For example, airbags in cars which inflate upon collisions. Therefore, when does safety become important? Again, when the human cost of failure is high, as we saw, it could be airplanes, ships, etc. failing. There have to be safety measures. When the environmental cost of failure is high, that is, accidents in a nuclear power plant, if safety actions are not employed, it can cause huge damage to lives and environment. These are some scenarios where implementing safety features in the system become very important. Summarizing, we looked at the conceptual difference between reliability, availability, and safety. While reliability focuses on minimizing failures, availability focuses on keeping the system up and running despite failures and also minimizing the downtime of the system. And finally, safety demands timely, fail-safe actions to protect humans and environment. Thanks for watching.